Right, now, just key terminology that we need to know. The size of a test is the probability of a type 1 error. And again, quite often, it's the significance level. Now, the power is 1 minus the probability of type 2 error, i.e. the probability of not making a type 2 error. Basically, it gives you how sensitive it is, all right? And you want to have an idea of how sensitive your test is, right? So if I say lambda is 2.8, and in fact, if lambda was 1, there's still a really high chance of me making a type 2 error, then it's not a very sensitive test. This test, is it very sensitive? Well, bearing in mind that we thought it was, so in our test we're saying 3.2, right, per week. If the actual number of sightings is 5 per week, we still have a 56% chance of accepting, right, of not rejecting. So we've got a 56% chance that even though the actual number of sightings is 5, we've got a 56% chance of concluding that it is actually 3.2. That seems fine. So the idea is that this is not a very sensitive test. It doesn't pick up on small errors, right? It doesn't pick up on small variations of what I should get particularly well. So it's got a low power. So 20 bulbs, I'm going to very much paraphrase this one because we're running over. We got 20 bulbs, probability of 0.1. The test rejects H0 if 4 or more defective bulbs are found in the sample. So the size of this test, well, it's just the probability of rejecting. So what's the probability of rejecting? That is the probability that X is bigger than or equal to 4. So let's go here. We want a right-hand tail. We want bigger than or equal to 4. N is 20 even. P is 0.1. So 13.29. All right, so that is my size. And it is the probability of a type 1 error. Okay, i.e. the probability of rejecting H0. Now, what if the actual true proportion of the defective bulbs is actually 0.2? Well, then X would have a binomial. Oof, I think the laptop needs a break. Now, what is the probability of not rejecting